Okay, this problem is a word problem that says that the distance to the horizon that you can see from a tall point, which has a altitude, or an h, as you know the altitude is, that you can see to the horizon, where distance is here, is given by this formula. Distance that you can see to the horizon is equal to the square root of 3/2 of the height that you are looking from. Now, they've asked you to find from this building in Chicago that has a height of 607 feet. This is a calculator problem, so they're asking you in miles how many miles you can see, because distance is going to be given in miles if the height is given in feet. So you're just going to plug 607 in here. So, and how you do this on your calculator is you need to hit the control and your x square button, which has the root sign above it, because the blue control button will give you the second function. Now, I can do 607 times 3, or 3 times 607 times 607 divided by 2, and then press enter. So there's the series of buttons that you're going to hit. You're going to have to hit the square root sign first on this calculator. And the reason I don't need any parentheses here is because it's going to do the multiplication first and then the division, which is exactly what I want. So now, after you do this, you should get 30.1745. If you hit enter first, you're going to get this in rational form. If you hit control enter, you're going to get the decimal approximation, which will give you this. The enter key has the approximately equal to sign above it, so you have to go into the second mode to hit that, and then you'll get your decimal equivalent. Now, the book doesn't say, but you can round this off to the nearest mile, so 30 miles. Now, the second part of this problem was to take the formula and solve for h. A lot of times, formula transformation is what we call this, is formulas are a lot easier sometimes when we just plug something in. It was a lot easier if we knew the height of the building. What if we know the distance? We need to solve for h. Well, in this case, I have a square root. Remember, I have a square root of a variable now, so what you want to do when you're solving for h is you want to square both sides, because you've got a radical over here all by itself. So if I square this side, I just get 3/2 h is equal to d squared. Well, now if I'm solving for h, I just have to multiply by 2 and divide by 3, and that's the same thing as multiplying by 2/3. So if I multiply this side by 2/3, those cancel out, and I get h is equal to 2/3. Remember, I'm multiplying this side by 2/3 also, d squared. Okay, if you remember from geometry, you're given an isosceles triangle. Remember that the legs of the isosceles triangle are your two congruent sides. So PR and PQ in this triangle are the two sides that are congruent. Part A of this problem asks us to show that the length of PR is equal to the square root of 25 plus x squared. It's really not that difficult when you think about it. You get a right triangle in here because this is an altitude. So you've got Pythagorean theorem. And I know that in an isosceles triangle, the altitude joins the midpoint of the opposite side. So this side is equal to 5, half of the 10. So we have Pythagorean theorem. This is the leg of the right triangle, 5 squared plus the other leg squared, x squared, is equal to PR squared. Okay? Now remember, PR with no line over top of it is the length of the side, not line segment. Okay? Now, if I want to find out what PR is, I have to take the square root of both sides. Well, this is 25 If I take the square root of both sides, I get PR is equal to the square root of 25 plus x squared. And that's part A. Now the second part said that if the perimeter of the triangle, and the triangle they're talking about is not the small little rectangle now, they're talking about the PQR triangle. If the perimeter of PQR, triangle PQR, is equal to 3 times PN, well PN is equal to x, so this is equal to 3x. Well, the perimeter is also equal to two legs, which are congruent, which we already know the length of those, and we know the length of the third leg. So we have 3x, our perimeter, is also equal to the 10 plus 2 of these legs. And now all we have to do is solve for x. I know, I say all we have to do, but it's really not that difficult. 3x minus 10 equals 2 times the square root of 25 plus x squared. Now I'm going to square both sides now with the 2 here, because again, if I divide by 2 I get 3 halves x and minus 5, and it's just easier to square it this way. So squaring both sides, I get 9x squared minus 60x plus 100 equals 4 times 25 plus x squared. Well, distributing this 4, I'm going to get the 100 plus 4x squared equals 9x squared minus 60x plus 100. I got the 100 on both sides, they're going out. So now I have 9x squared minus 4x squared gives me 5x squared. I have a minus 60x equals 0. So now I'm going to factor out of 5x times x minus 12 equals 0. Now x can equal 0, which it would be ridiculous to have a height of 0, so right away that extraneous root can be thrown out, and x is equal to 12. Okay, the check is left up to you for this, but that's the answer to this.